Hello students, this is Dr. Sourav sir's class. We are now solving the UPSC Mathematics Optional Paper, Paper 2. So, this question came on 2024 and it's of our Cauchy General Principle of Convergence. Examine the convergence of the given sequence. Now, we are tasked to analyze the convergence of the sequence, which is our this. Now, the sequence represents the partial sums of the series of this. Yeah, and we all know that this goes to our E. But now it's not irrelevant here. So what can be done? So which is known to the converges to E converts to E and the base of natural logarithm. So now to examine the convergence using Cauchy's general principle of convergence, we have to proceed as follows. So how our Cauchy's principle of convergence? What is this? This says us that a sequence is this is said to be convergent if for all given epsilon which is arbitrarily small greater than 0, then there exists a positive integer n such that our fn minus fm is bounded to be epsilon for all n and m greater than equals to n. Okay, in this case the same thing will have to happen. Then to check the convergence, we consider absolute difference between two terms Fn and Fm. Let, without loss of generality, we take our m is greater than n without loss of generality. Then what will happen? Let me change my color first. Okay. Now then what will happen? Then it will sorry, I wanna take this. Okay, let or n is greater than m without loss of generality. So this thing is equals to our summation of k equals to m plus 1 to n, and it is 1 by k. If we take the n, so our nth term it will be 1 plus 1 by 1 factorial. The terms go to the 1 by n factorial. Then if we break it at our 1 by m factorial, then the rest of the terms will come here. Will come here. So we have to now analyze the difference. So the difference this is given by the sum of the terms from m plus 1 to n. Each term 1 by k factorial, 1 by k factorial decreases rapidly. They decreases our rapidly because factorials grow very fast. So thus for large m, the terms 1 by k factorial become arbitrarily small. Okay, now we have to bound the tail of the sequence. Now let me change color first. Okay, now our for n greater than m, consider the tail sum that is k equals to n plus 1 to n1 by k factorial. Yeah. Up to infinity the term will increase, and up to n the term will smaller than it. So the infinite tail sum starting from k m plus 1 to infinity. This sum can be bounded by noting that, let me shift a little bit. Okay. So now this term can be bounded by our this 1 by m plus 1 factorial. Then it will be 1 by m plus 2 factorial. Yeah. Now for large m, the dominant term is our this. These terms are lesser, lesser, lesser. So the dominant term is this. So now the rest of the terms are negligible due to the rapid functional growth. So we have to now conclude using Cauchy's criterion. So now for all epsilon greater than 0, when epsilon is our arbitrarily small, so choose that thing is okay. So then for all n and n greater than equals to n, we have our mod of fn minus fm will be less than epsilon. Yeah, because this thing happens, so this thing will happen. So thus our fn satisfies that what by Cauchy's general principle of convergence, the sequence converges. In fact, the limit of the sequence is we have written it five. We have written it in okay. This thing we will go to E. So by Cauchy's general principle of convergence, the sequence if n is our convergent, and now our E limit, yeah, n tends to infinity, f of n will go to 1 E. Okay. Thank you guys. Hope you understood. Thank you.